related to visual survey, starting from crack pattern for intrinsic cracks in concrete. We looked into manifestation of certain types of deterioration, like we in last two classes, in fact we looked into those, especially related to alkali aggregate reaction. Earlier we saw shrinkage cracks, then plastic settlement and all that, and then we looked into cracks related to some of the deterioration processes which we are now continuing. We looked into alkali aggregate reaction cracks in details, also looked into freeze thaw, and now we will look into effects of corrosion where we stopped in the last class. So, what I said was in the last class that corrosion effect is something like this. Normally to start with we stopped somewhere here. So, this is your rebar and the concrete in the surrounding. Now, as the process of active corrosion starts, corrosion product which occupies 3 to 4 times the volume than that of steel, because corrosion products, the oxides, hydroxides, their densities are much less compared to that of iron. So, they occupy more space. So, initially they will fill in the spaces around the rebar, they will fill in the spaces around the rebar, and then gradually the more product comes in, they will actually exert pressure to the surrounding concrete. And further to that, as it exerts pressure, like in case of a tube, if pressure is exerted in all direction, so it causes crack into the, tensile stresses are generated along this direction, because the periphery will try to expand and finally you will find crack of this form. So, tensile stresses resulting from expansion actually finally cause cracking. So, that is what it is, and then it manifests itself in the form of, say for example, in beams you might find that for initially some cracks will appear, visible cracks will appear along the length of the rebar, parallel to the rebar, in case of beams in both the direction, because the covers are usually same. If one side cover is less, then first it will come on that side, then later on onto the other side. So, you will have cracks of this form, then chunks of concrete will come out eventually, because further pressure develops. In case of slab, first of course, the cracks will, internal cracks will generate, but that would not show up much till sometime later when there will be sagging of the slab, and finally something like this chunk of concrete will fall down. So, spalling of concrete will occur. So, this is the manifestation of corrosion, but then you can detect quite early. If you see rust staining, moisture marks, then you have already you have started detecting them early, and later on you can, if in some later stages obviously the cracks will come, they will become wide, and if you break it you will find rust there. So, examples are, typical examples are something like this. This is the next a case where already a lot of corrosion has occurred, then you can see the rusted rebars and the concrete has fallen off. So, that is almost in a final stage. This is a case, interesting case, they actually repaired it from the bottom, a staircase slab, it is something like this, staircase slab, something like this. I mean, you have something of this kind, So, the slab is something like this. So, these people what they have done, they have actually repaired it from bottom, by doing gunniting, did not do anything else. Now, they did not stop the cause of corrosion, corrosion continued, and eventually the repair cracked. So, this is an, I kept this example, this is a real case, corrosion crack. So, if the repair is not done appropriately, the cracks might come again and again. This is a case of a beam, and this is again lot of spalling has occurred. They did not initially did not pay heed to it, so a lot of spalling has occurred. So, this what could be this beams, sunshades very common. You will find something like this. the parapet, below parapet there is a lot of cracks, the sunshades have gone here, it started spalling. So, that is the kind of manifestation of corrosion. So, if you see rust staining, if you see cracks with rust staining, then you might open the crack and you might find there is an expansion has occurred, and it must be parallel to the rebar, right. So, corrosion can be identified very easily. Now, next is sulphate attack on concrete. Now, sulphate attack results in formation of calcium aluminosulphate, as we call it C3A, S bar, some H2O would be there, So, these are called ettringite, calcium sulfoaluminate. So, C3A will react with calcium sulphate and form this sort of thing. Now, this is white in color. So, you will see all white, and cracking is patterns are, because it is internal cracks, so expansion occurring within, it will not follow any rebar line or anything of that kind, and white marks will always, you will get calcium sulphate, white formation of calcium sulphate, because normally calcium hydroxide is there in the cement hydrates, sulphate comes from outside, usually in form of sodium sulphate, sometimes maybe directly as in the form of calcium sulphate itself, but often it is because sodium sulphate is soluble, sodium sulphate, potassium sulphate. So, they come in that form, react with calcium hydroxide, forming calcium sulphate, and then this calcium sulphate reacts with the C3A hydrates, forming ettringite, etc., or this is the white marks. So, you can see the white marks of calcium sulphate and ettringite, and a lot of salt is there, and crack patterns are of this kind, random, I mean you do not see really. So, you have to actually visualize the expansion, how can it happen, if there is an internal expansion, how can it happen, right. So, this is external chloride coming in. Now, this is an example of an internal chloride that I came across, 8 months old concrete, cracks vertical direction inside, flat slab construction. Now, chunk of the concrete even came out from the center of the column, spalling has occurred, particularly in the corner, I mean at the center height in the corner. This is, I suppose there is another diagram, or if not I will see, something like this. The corners have, it has come out from the corner concrete exposing the rebar, somewhere like this it is exposed, and at the center of the bar. Now, the center of the bar, if you have vertical cracks, either the buckling is occurring, right, either it is buckling, but the dimension of the column was very large, something like 750 a meter, square, a square column, 750 nearly close to 800 or so, nearly close to a meter size, very large size, 8-story building. Now, height is about 3 meters. So, if you see L by D, 3000 by even 750 if you take it, it is only 4. Now, it is actually a short column, very much short, long column is 12, L by D is should be 12. So, this is short column, no buckling is possible. In 8 months old concrete, it is not possible to have rebar corrosion or similar sort of thing. So, then all that, there are horizontal cracks also, and especially in the corner. Now, visualizing this stress pattern, what I thought was that there must be the crack pattern, so this concrete spalled off, because there will be stress concentration there. So, as if there is some kind of an internal pressure. If there is an internal pressure, that would first result in these corners to go off, zone of excess stress, right. So, stress concentration here, less area to resist the force, and this kind of the chunk of concretes were seen to have gone from those corners, but rebar protected them. Those were, even if the pressure is there, supposing there is a rebar, it would protect, will not allow the concrete to go away. So, leaving the rebar, surrounding concrete has gone away, and the cracks have also developed in some places like this vertical crack. So, this was my first conjecture. Looking at that, this must be because of some internal pressure. Now, in a new concrete which is about 7-8 months old, internal pressure can come from where? It must be from the cement system, and in cement if you have unreacted sulphate, gypsum remaining, excess overdosing of gypsum or something, and it remain unreacted or delayed attringite formation, that normally occurs in case of course pre-stress concrete, what they call delayed attringite formation. Here this was not a pre-stress, it was ordinary, but somehow or other possibly there is some calcium sulphate came from somewhere, possibly might have been from cement itself. They tested the water, they said there is no sulphate in the water of curing or anything of that kind, but there was some sulphate. So, to verify this, of course, we did instrumental test and X-ray diffraction of the product. Now, when you do X-ray diffraction of the product, then it was at around 9 degree and 18 degree, you see normally this for normal concrete, normal hardened concrete, XRD of concrete specimen, right, generally produced from ordinary cement and good water. So, this is the X-ray diffraction pattern of normal concrete. We do not find attringite peaks there after 7-8 old concrete, we do not find, but this concrete when we looked into, there are always attringite peaks. In X-ray diffraction you find out the crystals, because I am not here to explain much of the X-ray diffraction, because the X-ray wavelength is such that it can get diffracted from crystal planes. So, this is, if there is a crystal plane is here, another crystal plane is here, the first ray will diffract from here, get reflected from here, and the next ray, some ray will get reflected from the, and if this is the D, then these two, since it is a coherent source, right, these two can interfere constructively depending upon the angle of incidence, because it is related to path difference should be equals to n lambda. So, you can actually show Bragg's equation 2d sin lambda is equals to n 2d sin theta is equals to n lambda. So, I am not interested in this. All I am saying is by X-ray diffraction you can identify crystals, attringite can be identified, and this is exactly what was done in this particular case. So, we compare with the normal concrete, normal hardened concrete, where no X-ray no problem would be there, but then this particular one concrete, what we find was there are patterns of attringite possible, which means there is a sulphate attack. So, confirming sulphate attack, first thing is of course you will have visual observation will show cracks of the kind that I showed earlier. You will find white crystals, and you want to further confirm, you can do some analytical testing like this, analytical testing like this, right. So, this is how we do it. There are other cases also, if you go and see perhaps some cases where sulphate attack has been extreme. Say I came across one of the chimneys of a thermal power plant. Now, you have sulphur dioxide comes through as flue gases. So, internal lining of the chimney was gone first. They did not repair it, the lining somehow or other was not there, and the concrete got exposed to flue gases. Moisture would be present. So, sulphur dioxide reacts with water forming sulphurous and then oxidized to sulphuric acid, and therefore, this sulphate part of it attack the concrete. So, you find white crystals all over the thing, and when you scratch it you find that simply the powdered white colored things coming out. If we did not do further, because the client was not interested in doing further investigation at that point of time, otherwise one could have done actually test them either chemically for presence of sulphate or do X-ray diffraction as I did to find out the presence of sulphate. So, that is how we can find out sulphate attack cases. Acid attack cases are something like this. You might find simply powdered concrete, simply concrete, the acid when acid attack, because concrete is alkaline. So, you find lot of leaching has occurred of the mortar. So, this is the kind of photograph of acid attack, right. Quite often it can happen in some of the waste drainage lines, pipe because industrial effluent or something, the acid is there, it can attack. And see, the concrete is alkaline. So, even at pH at 7, there is a tendency of some leaching, and at pH at 4, there will be excessive leaching and weakening of the surface concrete. So, these are the signs of some acid attack, but you just can't, I mean these symptoms, the first thing is you have to also get the history, document survey done or history known, that there is a possibility of some acid coming, and then you find something like this, then you can diagnose this is acid attack. Okay, so these are all the durability related attack that I talked about since last class. If it is fatigue or structural cracks, then you will get something of this kind, the flexural beams, the load, because at this point near the support, negative bending moment, so flexural cracks, fatigue also over the long period of time. If you have not seen it in the beginning, might have seen it long period of time, after long period of time it might be like this. Poor concrete in the very long run, right, might show huge deflection and cracking at the structural level. Very poor concrete, I mean we just came across one of the cases. The concrete was extreme, when we tested the concrete is extremely poor. So, it shows all flexural cracks in beams, shear cracks, inclined cracks resembling structural cracks, and then we tested the concrete, it was FCK was coming somewhere around 9, so bad concrete. Then we calculated the creep effect, did not see the crack in the beginning, after 10, 15, 20 years they started observing cracks. So, if you calculate out the creep, take the creep coefficient etc., specific creep coefficient etc., and calculate out, effective modulus reduces significantly after 20, 25 years taking the creep effect, and it showed up when you take that the modulus is low, and therefore deflections and cracking can occur. Fatigue is also a long term behavior of the similar kind. So, structural cracks can be identified by looking at the nature of the cracks. Maybe I will have some more diagrams of structural cracks later on, but they are relatively less common because both design and construction fault both must be there, particularly if it is extreme construction fault like the case just I was mentioning, but most other cases it will be design fault also, then only you find that maybe steel they have missed some steel during construction phase, poor concrete, all this can result in structural cracks. So, normally structural cracks are not very often occurs, damages can occur because of excessive loading, but that is separate. So, one can actually record this visual survey through visual survey codes. For example, as I said, you can I think I must have mentioned earlier, now this is for corrosion. So, minor, moderate, extreme severity you can talk about. Then description, I think I have talked about this similarly earlier once, and this again I am saying, and you can do the code like this. So, visual survey somebody is doing can use this kind of code which I talked earlier. Again another scenario I am saying, rust stain for corrosion, you have observed rust stain, then you see first some moisture marks can be seen, but not rust stain visible. Then this is the state, state, then extent nothing is this you are not bothered about, but some widely spaced small size light colored patches of stains are you are seeing. So, this is rust staining. If you have just seen rust staining, no corrosion cracks, then locally this is local, not over spreaded over area, global this is over very large area. So, it is corrosion stain moderate local, because this is moderate local. So, you can codify this and record in your visual survey record simply this with a photograph, maybe that is good. And similarly you can do for extensive extreme global situation where there are large area, you find lot of significant one dimensional minor cracks visible in the direction either stirrup or longitudinal main bars, because it is parallel to bars all over the surface. So, you can have coding of visual survey coding can be done in this manner, right, which I have told earlier also. So, this is for example for a reinforcement corrosion in a slab, and this therefore would be something like this global, because it is all over the place, whole of the slab is gone. So, we call it global. If it was only over a small area, instead of all this, maybe just this corner I had something like this and rest all is all intact, then I would have called it local. This is global, sorry, this is global, and then depression of size more than 20 millimeter in depth and or any other dimensions greater than 100 millimeter are visible over the significant proportion of surface. So, this is corrosion, spalling, extensive, global. this kind of complete code actually we have developed, actually it is available, I mean if one wants, and then such coding you can put together and come out with a kind of a index for the whole building, first for the element and then for the building. For example, like element number, right. So, this is the code, and this is, so the codes are something like this. Now, you can combine them, and we have developed actually a mathematical tool, although I am not teaching you here, but you can yourself also develop some kind of tool to come out with a kind of an index, so that you can relatively compare. And if you get that index for the whole building, you can compare this from previous years, 5 years earlier to now, and how it is likely to progress in future, some ideas you can get. So, using index, equivalent single index for the building, first for the element, combining those elements together, I get for all the buildings. Some buildings may have only 1 or 2 elements affected, another building might have many elements affected. So, combining all this, I can get index for the whole building, and comparison can be done with another building if you have past experience. Okay, this is very bad, this is not so bad, requires repair immediately, or I can delay the repair. This sort of decisions can be taken. Such state metrics and codification of the state of defects or distress can easily be done for any other kind of thing also. So, this is just as an example, right, and then we will come to, okay, this is something different, this for a specific case. I will come back to this later on, because I have not already told you. So, this was related to visual inspection, right. Now, I will come to this, but I think, do I have anything related to visual inspection available here? If it is not, I will come back to, I will just come, because this is related to, just quickly I will come back and look into this. Okay, right. So, essentially number of yeah. So, this is related to number of tests we got to do finally. So, in order to understand that, we got to understand a little bit of variation of properties in concrete. For example, if you look at it, we will see that we measure hardness, surface hardness of concrete through something called rebound hammer test. Now, if you test a large number of them, and then you have got a range from somewhere around, let us say 20 to 45 or some such thing, range of this rebound number. What is rebound number? I will explain you later on. Then you can divide them into classes, class intervals as we call it, whose mean, for example, here it is 24.2, 28.2, 32.2, and then number of results that falls into this class interval, that you can. So, that is a histogram plot. Normally, it is expected that properties of concrete would vary normally, normal distribution. What is normal distribution? I am sure you are familiar with, but even if you are not, I will give you a brief, quickly I will tell you what it is. Now, so anything you measure on concrete, it is likely to show a variation of this kind, a peak, and then symmetrically distributed about the peak, right. So, for example, strength, variation of strength, if I look at it, and large number of cubes I test, and I plot similar histograms, frequency histogram, I get variation, and which I can fit with a bell shaped curve. Now, why it is so? Because properties of concrete depends on any property that you measure on concrete, large number of measurement you take. You see, there are many factors which will actually affect the properties. For example, strength, if you look, or surface hardness. Now, strength would depend upon, first of all, proportions, variation in proportions. There could be from one cube to another cube, there can be variation in water cement ratio. You will not have exactly same water cement ratio for all. Or if you go to actual site and take rebound number, every point you will not have same proportions. Rebound number you will not same, but say proportion might be different, right. So, that is number one. Also, the compaction level may be different, and many such factors, not one. So, when you have many such factors, the tendency would be to vary in this manner. Slightly going a little bit more, because many of you wouldn't have taken my concrete technology course or similar course. For example, you know, I think I might have told you earlier when I was talking about services, and I must mention about normal distribution. I told you about a case of a die. Did I tell you about this? Yeah. So, this reminds you, if you have too many number of factors, you know, controlling your measured property, right, even if the individual factor varies uniformly, their sum total, you know, too many factors affecting the property would essentially lead to a normal distribution. I think I have already talked about it in my earlier service class. So, therefore, concrete strength is also one of them. So, it varies normally. So, normal distribution for concrete, normal distribution for concrete, right. So, concrete strength or you know, any other property actually exhibit normal distribution. And we define our characteristic strength, right. So, this has got two parameter, one is the mean, another is the standard deviation. So, these are the two parameters which describe. Standard deviation explains, you know, rather is a measure of the dispersion, and mean is the central tendency, you know. So, it is actually the distribution is symmetric about the mean, both sides same. So, the peak, what is called, we call it mean mode, and median, all are at the same point in case of normal distribution. So, this also we know that if I normalize it, I get the total area under the curve as 1, and total area under the curve as 1, and this side, this area is 50%. So, 50% of the samples will have higher value than the mean value. So, for example, strength, in case of strength, you have tested large number of samples, 50% of the samples will exhibit strength more than mean, and 50% will show less than mean, because mean and median are same. Median is the one which corresponds to 50% of the samples, right. And this is up to one standard deviation you go, this area is 34.1%, this is 13.6%, 2.2, and so on, so forth. So, this is how, you know, the behavior of, I mean, normal distribution behavior is like this. So, okay, one can calculate out the mean for small sample, one can calculate a measure of standard deviation as S square, this we know. Now, in case of concrete, of course, we talk in terms of characteristic strength of standard cube, right, FCK. So, FCK is defined like this, only 5% of the samples will show result less than. And in structures, I would like to know what is FCK. I would like to know FCK. So, 5% of the, so it is somewhere here, mean is somewhere there. So, FCK plus 1.65 sigma, because corresponding to 5%, area this 5%, it is 1 sigma distance away from the mean. So, mean is FCK plus 1.65 sigma, all right, 1.65 sigma, mean plus 1.65 sigma. So, that is what it is. So, at site I would like to find out this FCK, that is why later on we will talk about this, but also the normal distribution concept is required to understand the number of samples you should be testing in order to get a given, you know, have all the results within given error. So, when you have large number of points, it is something like this, right, normal distribution. But supposing I take some n number of samples and find out their mean, then find out their mean, right, n number of samples, find out their mean, and then again take another n number of samples, I find out their mean. So, each mean, let me call it as x1 bar, x2 bar, etc., and I repeat this process x m times, right, or large number of times. Then this means will also be distributed normally, because, you know, they will also show normal distribution, because I have picked up randomly n number of them, but they will have less standard deviation, because the mean spread would be less, because it depending upon number of n. If my n is very large, spread will be small. If n is 1, then it is same spread as the original and parent distribution. If n is 1, it will have same parent distribution, it will be same as parent distribution. But if n is infinity, then standard deviation of this means will be 0. I will just explain further more onto this. So, this distribution of this means we call it distribution of sampling means. If I take set of means, set of sample and then find out the mean, and now mean of the means and standard deviation of the means I can find out, because I can find out the distribution of those means. This is we call distribution of sampling mean, distribution of sampling mean, distribution of sampling mean, right, distribution of sampling mean. So, distribution of sampling mean, this concept is used because that is why you do not test one sample. For any test you are doing, either lab or in situ, you will test a number of them and find out their mean, and that mean is supposed to represent the true mean, true value, which is the mean of the population, as we call it, large number of values. So, true mean, the mean of the means, that is the mean of the sampling mean is represents the true mean. But then if this is the distribution of the sampling mean, you might get a value here or you might get a value here, because you have taken you have taken let us say 4 number of samples or 3 number of samples, found out their mean. Now, this mean will have a distribution spreading over, this spreads 99.95% or 99.9% of the time. So, you might get anything within this, but if I want to get closer to this value, then I might take large number of samples. More the number of samples, this spread will get little closer to this, your error will be less. That is the basic concept of if you have more number of samples, you will have higher accuracy, less error. If you have less number of sample, then you are likely to may not be away from the true mean.